Today I will be going over a tutorial on how you can solder your first circuit. In order to start soldering, I'll be going over the list of materials that you'll be needing to solder the components for your first circuit. And to start, you'll be needing some solder wire, and these come in two types. The first type of solder wire that I have here is lead-based, and it's usually around 60% lead and 40% tin. Inhaling the fumes of this heated solder wire can lead to long-term health issues. But it has a lower melting temperature and it has a much more stickier feel to it, which for a beginner could be much more easier to use. The other type is a lead-free solder wire, which I currently use. It doesn't pose any long-term health issues, though it's still not recommended to inhale the fumes of the lead-free solder wire. And you can distinguish the two types mainly by its color and how shiny your solder wire looks. Lead-based solder wire is more dark gray in color and is less shiny than the lead-free solder wire. And the lead-free solder wire I here, as you can see, is more in a lighter gray color, and it's more shiny than the lead-based solder wire that I have here. Another distinction is that for lead-free solder wire, instead of being sticky, this one feels more like a liquid when you melt the solder wire. For my electrical engineering work, I always pick the lead-free solder wire, and I will only use the lead-based solder wire if there is a specific reason that I will need to use it. You will also be needing a soldering iron. Now for a soldering iron, you have to make sure that you can at least adjust the temperature that your soldering iron works at. And the metal part here is where you shouldn't touch, and is the part where you'll be melting your soldering wire. You also have the soldering tip, which if I unscrew my tip holder here, you also have a soldering tip that you'll need. And these come in different shapes and sizes. For my preference, if I'm working with a through-hole component board, which I'll talk about a little bit later, it looks like this. I'll be using a soldering tip that's more conic and less flat at any side at all. So as you can see, I rotate the tip. If I'm working with a surface mount device board, which looks like this, as you can see, there's no holes. Everything is just soldered to the surface of this board. I would be using a soldering tip that's more flat in the surface. So here, it's flat on one side here, and also flat on the other side. It still looks conic, but I like using the flat side of my soldering tip because of the surface area that I'll be working on my surface mount device board. Now these soldering tips do need to be replaced over time. It can be because they look too corroded and can't transfer any heat well, or the reason can be that your soldering tip is damaged, like this soldering tip I have right here. The top part, as you can see, there's a hole here, it's damaged, it's not going to transfer heat well. And if it's also corroded, as you can see there's a little bit corrosion here, it's also not going to transfer heat well. For me, at least, I have to replace the soldering tip once per month. And they're relatively cheap too, as a soldering tip will come around only for $1 a piece. You'll also be needing a soldering tip cleaner, which is pretty much just brass shavings. And you would just clean your soldering tip in your brass shavings like this. And you would get a shinier tip that looks cleaner at the end right here. In order to preserve your soldering tip life and in order to get better heat transfer of your soldering tip when you're melting your soldering wire, you'll also be needing a PCB board, as we talked about a little bit earlier. There are two types of soldering that you can choose from, and one of them is by a through-hole component board, and one of them is by a surface mount device board. And I'll be going over a little bit later on how you can solder by using both types of boards. Next, you'll be needing some soldering flux paste. Soldering flux paste makes heating up your solder wire much more easier. and it has a variety of different applications, which, for example, you can use it to easily attach your components together or to easily remove solder from your components. And I like to use it as a syringe because it distributes the solder on my board very easily. To complement the soldering flux paste, you'll also be needing a soldering wick. Now, a soldering wick is a copper braid that absorbs the solder into the braid when the solder is heated up when pressed against the soldering wick. I'll be demonstrating how to remove solder using the soldering flux paste and using the soldering wick a little bit later into the video. In general, just think about your soldering wick as your eraser if you want to remove components in your PCB board. You'll also be needing some tweezers, and these tweezers can come in different forms. I like to use these angled tweezers to easily add or remove my surface mount device components. And these tweezers here, which would be perpendicular to my circuit, is what I like to use for my through-hole component PCB board. You might find out that you might want to use a different type of tweezers, but this is my preference and what I like to use. You'll also be needing some insulated copper wire, and I have the wire size at 24 AWG, and AWG stands for American Wire Gauge System. And I would recommend getting at least a spool of red wire and a spool of black wire. And to cut the wires, whether it's on a spool or whether it's on your PC board, you're going to need some micro cutters, and make sure it's angled so that cutting the wires is going to be easier for you. You'll also be needing some wire strippers, and this is what my wire stripper looks like. And a wire stripper pretty much works by stripping off the insulation of your copper wire. And to demonstrate this, I have my spool of red wire and putting the wire through this tool here. I can strip it like so. And this would be the result, just my copper wire here. And you can see the insulation where I cut it through using my wire strippers right here. You'll also be needing a power source. And here for this video, I'm going to use a 3.7 volt lithium ion battery. You can also use a DC power supply, in which you have more options, since usually DC power supplies are adjustable. And finally, you're going to need some components to construct your circuit. And in this video, I'm just going to make a simple LED circuit. And for the components that I'll be using in my through-hole component PCB board and the surface mount device PCB board, I'll be using this LED, this resistor at 220 ohms, and this capacitor here rated at 470 microfarads for my through-hole component PCB board. The surface mount device components are much smaller than your through-hole components. And just for comparison, this is my LED for my through-hole component PCB board, and this is my LED for my surface mount device PCB board. This is the capacitor. Capacitors and through-hole components are usually black and white, and capacitors and in surface mount devices are usually tan in color. And we have our resistors. Resistors in surface mount device boards are usually black and white in color, and resistors in through-hole components are usually bluish in color, with color band on them indicating what the resistance value is. You'll need a soldering fume extractor for health reasons. And you can see the soldering fume extractor doing its job here. You can see the soldering smoke going into the extractor. And if you have an excess amount of solder on your soldering tip, just grab your tip cleaner and just rub your tip inside your brass shavings. And your tip here is ready to go again. It's also what people call tinning your tip, which you will have to do every couple of minutes. For lead-free solder, you want to set the temperature around 650 degrees Fahrenheit to 700 degrees Fahrenheit. And that's the effective temperature in which you can melt your solder into your PCB board. Another tip that I would like to give, whether you're soldering through-hole components or SMD components, is that the order in which you should solder your components should be the smallest ones first, like a resistor, then moving on to bigger components, like your capacitor. And the reason for this is that you want to make your components as flush as possible to your PCB board, and it'll be easier to attach if you use smaller components first. With that in mind, let's start soldering. I'll turn on my fume extractor and my soldering iron, and I'll go through the through-hole components first. To solder a resistor into your PCB board, just put the leads into the holes and make sure it's flush with your PCB board, just like this. And if necessary, use some tweezers to hold them together so that you won't burn your fingers when you're soldering leads into your PCB board. Next, you will get your soldering iron. Do not touch this, you will burn yourself. Go ahead, melt a little bit of solder on your soldering tip, and attach the solder to only one lead of your component. So as you can see here, doing this like so. And to get a closer look. Now, it doesn't have to be perfect initially, since the first lead that you use the solder on is just there to secure the component on your PCB board. And now for your second lead that hasn't been soldered yet, you can go ahead and remove your tweezers. Melt a little bit of solder on your soldering tip again to your other unsoldered hole. And it doesn't look perfect at first, but you can adjust this by heating up the spot where you soldered at, just like this, and adjust the flow of solder using your soldering tip. And you would do this until it looks good on your PCB board. So this is my final result. And now to do it with this side, as you can see here, put the iron on your soldering spot, add a little bit more solder if necessary, and try not to add too much solder. And you can keep practicing this with different types of components until you get the hang of it. And this is the result for my resistor. Your soldering joint here should look like a cone or a conic shape, and you would cut the leads afterwards using your micro cutters. And yeah, this would be your result. You can see the component is flushed with the PCB board, and if necessary, if you don't like how your soldering spots look, you can always adjust it using your soldering iron, and it'll look better. And just like this. Now, if you want to remove a component from your PCB board, you'll be needing your soldering flux paste, which will make heating your solder a lot easier, and you'll be needing your soldering wick. The first step is to use a little bit of soldering paste onto your point which you want to remove the solder on. So adding a little bit here and a little bit here. You would then take your soldering wick, place it on the point that you want to remove, and then placing the soldering iron on top of it to heat the spot and the soldering wick so that the solder can transfer into the soldering wick here. Doing it like so, wait a few seconds, remove it and check if all the solder has been removed. Here just a little bit more. And this is my result here. It's completely removed, and you would use your tweezers to remove the first part of your component. And you just repeat the same for your second part here. And you might want to use some helping alligator clips here, which I have one here. It can hold my component and remove it much more easily. And if I hold the component like this and use my soldering iron on my soldering spot right here, just heat up the soldering spot and take the component out. And let's say your soldering hole isn't completely clean, there's still solder on it, and I'll demonstrate that. So it looks like this instead. You can just add more soldering flux paste and do the same process again. Put your soldering wick on top, then your soldering iron, and let the solder be absorbed into your soldering wick. And yeah, this is my clean result. And be careful not to put it on for so long, otherwise the circular metal plate, which is right here, will come off. And you're going to need that for the solder to attach to your PCB board. And I have one of my projects here. to demonstrate what it would look like if you overheated your metal plate. And as you can see here, the metal plate is gone, the solder can't attach, and then you'll have a harder time attaching your components together, like this example here. And keep practicing too. You won't get it for the first few tries, but you'll get better at it. Just follow the steps that I said and you'll be good. I'm gonna go ahead and reattach this resistor. You would then attach your next smallest component, which in this case is the LED, to your PCB board. Now, one thing about LEDs to look out for is that it's polarized, meaning it has a positive side and a negative side. And the positive side of the LED has a longer lead length, and the negative lead has a shorter lead length. So this is my negative, this is my positive. And another way to tell is that inside your LED, the negative lead length will be the bigger piece in your LED. And the positive lead length would be the smaller piece in your LED. Another indicator is that there's a flat side on your LED, which is right here. And that would indicate that the LED lead right here is negative. So those are three ways you can indicate whether a side is positive or negative. And you want to attach your positive side to the hot wire or the live wire of your power supply. And you want to attach the negative side to ground. And I will go ahead and attach my LED to my PCB board. And remember, solder on one side just to make it secure, then solder the other side to make it look nice. Then you would go back to the original side that you soldered on to make that look nice. And you can hold your component to make it look flush. In this case, I'm gonna hold it with my hand because the top part is plastic and not metal. I wouldn't recommend this if this is your first time soldering. Use tweezers, which I'll demonstrate. So as you can see, I just attached the solder to my first lead. It doesn't have to look nice. It's just to make sure that my LED is secure on the PCB board and it's flush. Now you can work on the second side, then make the first side look nice again. And this is my result. Once you're done, micro cutters cut off your leads. And let's move on to our last and biggest component that we'll be using, which is the capacitor. And I'll attach it in a way that the electricity will go through the LED and the capacitor at the same time. And I'll go ahead and attach it like this. And yeah, this would be my result. And to solder the joints together, let's say from the LED to the resistor, you would just add the solder between the 2 points that you want to connect. And as you can see, like so. The resistor is connected to the LED and it's also connected to the capacitor. Now I'm going to solder a red wire, which is my positive point right here. And I'm going to solder my black wire, which is my negative point right here. And I'm going to connect my two negative points together. And yeah, so this is my final result. My positive or hot lead and my ground lead. My resistor connected to my LED and capacitor, as you can see here. And you can see my soldering joints that I've made too. Here's a quick summary of the circuit made. So we have a red wire connected to a resistor. The resistor does not have any polarity, meaning that the resistor does not have a positive side or a negative side. You can switch the direction of the resistor and it wouldn't matter. The resistor is then connected to an LED. The LED is polarized, meaning it has a positive terminal and a negative terminal. And this side here, this point here, is positive, and this point here is negative. The resistor also connects to a capacitor. We'll say that this line is our capacitor, this is the positive point of our capacitor, and this is our negative point. And I'm going to just draw an arrow here and say this is our capacitor. Then our capacitor's negative end has a black wire that connects this point to this point here. So we're going to go ahead and say this here is our black wire. Then finally this point here connects to ground. So we're going to do this and say it points to ground. I will quickly show what this diagram looks like using a schematic that uses the correct symbols. Here would be your positive terminal and your negative terminal of your battery. Here would be your resistor. Here would be your capacitor. And here would be your LED. This would be the positive side, this would be the negative side, positive, negative. And this overall is what the schematic for a circuit diagram would look like based on the sketch here. The next step is to attach these two leads to a battery or a DC power supply if you have one. For me, I'm going to attach it to this 3.7 lithium ion battery that I have here. And to solder two wires together, you'll need to twist one end of a wire to another, then add a little bit of solder to them for a secure connection. So I'm going to go ahead and do it like so. And this would be my result. And to add a little bit of solder on it, it should be secure. And yeah, this is my result. And you can add a tube around it called a heat shrink tube. I'll go over that a little bit later to make the overall wire connection look nice. Now, if we connect the hot wires or the live wires together, we will get our circuit. And to turn it off, back on, you have now made your first circuit. Congratulations. And that is by using through-hole components. If you're using a DC power supply, make sure to use 3 to 3.5 volts. And just a quick note before we move on, depending on the LED that you're using, they're rated to work under different voltage conditions. Like for example, if I have a red LED, it'll work from 1.9 volts to 2.1 volts. And for green, that'll be 3 to 3.2 volts. Just make sure to keep that voltage range in mind when testing your circuit. Now, we'll be making the exact same circuit using SMD components. Let's quickly go through how we can design our circuit using our LED, resistor, and capacitor. Starting off, we have our red wire coming in from our power supply, and this red wire is our hot or live wire. From our red wire to this junction right here, we have our resistor. And this resistor that I have right here is 330 ohms. And it does not have any polarity, so no negative or positive side for this resistor. And this resistor will go right here. And to get a closer view. Next, we have our capacitor, which for SMD circuits are usually not polarized, meaning that they do not have a positive or negative side. And if it is polarized, there would be a marking on this capacitor that would indicate which side is positive and which side is negative. And this capacitor here is 470 microfarads. And looking at my capacitor, this is the front view. And this here is the back view, side view, and as you can see, there's no marking on my capacitor, so this would indicate that this capacitor is not polarized. And if you want to double check this, you can use a multimeter for each side of the capacitor and just switch the leads on the multimeter to see if the display on the multimeter is showing the capacitance value for this capacitor on both sides. So placing our capacitor on our circuit diagram here, our capacitor goes right here. And just to zoom in, this is our resistor, this is our capacitor, and now we have our LED on this point to this point here. And LEDs for SMD components are polarized. And as I said before, components that are usually polarized have markings on them. And at the back of this LED, you can see a T-shaped mark. The side that has the vertical green line would be a positive side. And the horizontal green line, which is right here, would be my negative side. And to place this LED correctly, this here is our positive side coming in from the red wire, and ground is our negative side. So we would place it like this. And this would be our updated circuit. Now, your LED might have different markings. Mine has a T-shape like this. And another marking that you might see on your LED looks like a triangle. And to determine which side of your LED is positive and which side is negative, you can imagine the symbol of a diode, which looks like this. And you would know that this side is positive, and this point here of my triangle is my negative side. So this side here is positive, and this side is negative. However, if my marking looks like this would be my positive side, and this would be my negative side. You can kind of imagine this marking like a triangle if you formulate it. We have one more step before our circuit is complete. And what's missing is the black wire from this point to this point here. And I've cut out a little black wire, which I will place to finally finish my circuit. And place it a little carefully. And there we go, our circuit is finally done. Keep in mind that these components are incredibly small, so I really recommend that you use some angled tweezers if you want to hold your components or if you want to remove them. And with that in mind, let's go ahead and solder and desolder the resistor on our SMD PCB board. For an SMD PCB board, you want to limit each square or each pad to just one component. If you want to connect your components together, you want to solder between two different pads. Go ahead and get your fume extractor and go ahead and get your soldering iron, turn them both on. The first thing that you want to do is grab your soldering flux paste and spread it on the pads where you'll be soldering your components on. Say that I'm going to use this pad here, this pad, and this pad initially. Next, we're going to put a little bit of solder on each of these pads. Go ahead and put a little bit of solder on your soldering tip and put it on the pad. And it should look like this. And make sure you put solder on your pad one at a time if you're attaching a component. And here is the resistor that I'll be attaching to my PCB board. Go ahead, hold the resistor on one hand, grab your soldering iron on the other hand, heat up your soldering pad that you want to attach your resistor to, and place one side of your resistor on the heated soldering pad. And make sure it's flushed to the PCB board. So this here is my result. You can see my resistor. That's in line with my PCB board. And remember, only one component per pad. So if you want to attach another component, start on a new pad. And to finish attaching this resistor, we're just going to put solder on the other side. And just like that, we're done attaching our resistor. Now, if you want to remove your resistor, you're going to have to heat 2 soldering points at once. And you are not going to use a soldering iron for this. Instead, you will need a heat blower or a heat rework station. So this is the tool here that I will be using to blow my hot air and remove my resistor from my PCB board. And for this case, I'm going to go ahead and turn my soldering station off and turn my rework station on. And when you're turning this on, make sure that the blowing force is at the lowest setting so that you don't catch the risk of starting a fire. So once your hot air reaches 650 degrees Fahrenheit to 700 degrees Fahrenheit, you can go ahead and increase your blowing force and point the tip of your hot air to your component that you want to remove. And also make sure your tweezers is holding your component. And yeah, that's how you're going to get a component out of a SMD PCB board. When you're done using your soldering iron, go ahead and turn the knob for the force of your hot air to the lowest setting and turn off your hot air blowtorch. And if there's a little bit of solder left over, like this one right here, you can go ahead and just use some soldering flux paste and the soldering wick to remove the solder from your PCB board. I am going to go ahead and reattach the resistor. My resistor is now reattached to my PCB board. If you want to attach a new component, say like a capacitor that I have right here, you're going to have to make a new soldering joint. And that's just placing solder between 2 different pads. And I'm going to go ahead and demonstrate that. Put a little bit of soldering paste here. Add solder to your pad. And add more solder between the 2 pads that you want to connect. And this here is your result. Let's go ahead and connect the capacitor from this point here to this pad here. And remember, before you put solder on this pad here, connect one end of your capacitor to your solder point here. And you can see my result. My capacitor is connected. And this other end right here where my finger is pointing to is ready to solder. The last component that I need to attach is the LED. And I would attach it from this pad right here to this pad right here. This pad being the positive side and this pad here being my negative side. And I'm going to go ahead and solder my LED to the PCB board. And here we go. This is my finished result. The next thing that I want to do is connect this pad and this pad together. And I'm going to go ahead and make some soldering joints to connect these 2 points together. And this is my result. Finally, the last thing that this circuit needs is some wires so I can connect to my DC power supply. So I'm going to go ahead and do that. And there you go. This is how you create a simple SMD circuit. And now to connect it to my power supply, you can see my LED turning on. And removing my ground lead, it turns off, back on again, and yeah. And I know SMD soldering is a lot more challenging, so keep practicing and you'll get the hang of it. For this last part of the video, I would like to teach you how you can solder 2 wires together. And you start off by having 2 insulated wires that you would like to connect together and is stripped at each end, as you can see here. one end of this wire is stripped and one end of this wire is also stripped. And what you would do is twist the stripped ends together. And I'm going to go ahead and demonstrate how you can do that. And you would do that by one stripped end at a time. So let's do the right one first. Twist the right one. Give it 2 or 3 twists. Then give your left stripped end also 2 or 3 twists. Then you have a secure connection like so. What you want to do next is grab your soldering iron, then place the melted solder on your stripped ends that were twisted together, and evenly distribute the solder too. And this would be my final result, just rotating my 2 wires so you can see what it looks like. And if you have any pointy ends like this one here, go ahead and take your micro tweezers and trim your pointy end. So I'm going to go ahead and do it like so. Now it looks a lot better and is more secure. And if you want to insulate these 2 joints, you would use something called a heat shrink tube. And a heat shrink tube, which I have a case right here, would fit into your connected wires according to the wire size that you used. So I'm going to take my heat shrink tube and put it in my wire. And just to keep in mind, if both of your other ends is already connected to something else, put your heat shrink tube in first before soldering your stripped ends together. So I'm going to move my heat shrink tube inside here. And make sure to put the heat shrink tube to where you think the midpoint is. And now, either you're going to need a lighter or you're going to need your hot air wand. And I'm going to be using my hot air wand. And for this, I'm going to need some alligator clamps to hold this so that I can focus on evenly distributing the heat from my wand to my heat shrink tube. And here I got it set up. The tension on my wire is tight, and I'm gonna go ahead and turn my hot air wand on. And make sure the blower is at the lowest setting. And you wanna set it to 450 degrees Fahrenheit to 500 degrees Fahrenheit. Once your wand is at that temperature, you can go ahead and turn your blower level up and go ahead and heat your heat shrink tube evenly. And you can see the heat shrink tube shrinking. And when you're done with your hot air wand, go ahead and shut it off and go ahead and turn your blowing level knob to the lowest setting. And this here is our finished result. Overall, it looks a lot nicer, and I think you would agree with that. And with this tight connection, that's it for this video. I hope you found this information helpful. Thank you.